Hi everybody, my name is Avi, and today we're going to talk about domain-driven design. On the practical side, we see implementation with Akka, and we'll mention a little bit CQRS and event sourcing, but the main agenda will be about domain-driven design. On the 11th, we will have a Q&A session. So keep your questions in mind or write them anywhere, and we'll have another session especially for that. Sorry. Okay. So, what is about domain-driven design? There is a lot of buzz about it. It was first introduced by Eric Evans in 2014. Also published a book about it. And it's all about breaking the complexity of large applications design. Okay, so why or when should we use it? Well, first of all, it's giving us some kind of pattern to model complex applications. It encourages clear communication between the domain experts, and we'll get into that in a minute. And we will end up with clear, readable, and easy to reason about code for all parties. Even if we will talk to the domain experts, to other people in the organization describing our code, they will understand what we're talking about. Okay, so when we're saying domain, what does it mean? Well, this is a definition from Wikipedia. A domain is a field of study that defines a set of common requirements, terminology, and functionality for any software program constructed to solve problems in the area of computer programming, known as domain engineering. Also known as sphere of knowledge, is a bounded knowledge context. For example, a domain can be baking cakes, can be hardware shop, can be any kind of thing that you can think about, but it has to be bounded. And we will model it in our application. Okay, so I guess that some of you know this this drawing. It actually shows the difference between what the customer expected and what the project manager understood and what the programmer developed. I cannot count how many times I saw that in action. Actually, this difference. So domain-driven design actually encourage the communication between the domain experts, which can be if we look on an application, it can be the salesperson that is a domain expert in the sales domain of that specific business. It can be the accountant manager, which is also domain expert in that bounded context of the accounts. And I think that you get the idea what I'm talking about, domain experts. And the whole idea is that how they can speak together, the domain experts and the technical experts. When I'm saying technical expert, it's the engineering, the people that are doing the design, writing the technical documents and all that. Okay. So in the domain-driven design, one of the key aspects is the ubiquitous language, which actually defines, which actually align the terms that we design, that we use. So if the salesperson is talking about an item, then it's coming, I don't know, by a special name. then we will use the exact term in our code. So when we sit with a domain expert and we will explain him how our code look like, and we say the word item, then he knows what we're talking about, and not some, I don't know, when we say product, then he will know what product it is. So we use the same terms and not something like vague, so like something like entity or object or something like that. It's important that we will use the same terms exactly. Okay, so we said that the same language is used by the domain experts and the implementation experts. The important thing, the important takeaway from what I said until now is that it must be reflected in the code, in the implementation itself. Okay, so let's take, for example, case study, and we'll take a look at it again and again during this presentation. So for example, a cart auction. We have our shopper that takes the shopping cart, takes a shopping cart, and he starts filling it with items. And please note that I'm highlighting some actions and some terms here, because this is when we sit with the domain experts, we need to pay attention to the terms, to the actions, to the verbs and everything that he uses, because we want to use the same thing in our code. Okay, so when he completes shopping, we want to let him to start an auction on that shopping cart. Okay, when he starts the auction, other vendors can place some bids, and later on he can select the winning bidder. Oops, sorry. So after they place their bids, the auction finish, and the shopper can select his favorite offer. Very simple. Okay, and this is how the ubiquitous language will look like. So we have all these terms and verbs, and we will use them, the same terms and verbs, in our implementation, in the design documents, in the code itself. Okay, so another key building block in a domain-driven design is the bounded context. It deals with dividing actually our model to bounded context. For example, if we look on, I don't know, on any kind of business, I don't know, a hardware shop, then we'll have the clerk and the salesperson that they have their own bounded context. They are doing the sales. And we have the accountant manager that is doing the accounts, and he's also a domain expert in that bounded context. So every domain expert has its own bounded context. Later on, we can take those bounded contexts and separate them to microservices. Okay, so they go hand in hand with a service, but it doesn't must. It's not a must. Usually, when we need to make some kind of atomic action and we cannot divide that action to separatable actions, then maybe it should be on the same bounded context. Sorry. But I do agree that it's a pretty vague concept. There is no like straight line that I can tell you, you know, an accurate recipe how to define the bounded context. Okay, so we do have terms that are shareable in several bounded contexts. Some are are shared between different bounded contexts, some not. But what's important to know is that they have different meaning in every bounded context. For example, for the shopping cart, an item is just something that is in our shopping cart. From the seller context, it is just something that needs to be sold. From the shipping context, it's just something that needs to be shipped. So the same word appears in different contexts with a different meaning, but it's still the same item, right? Okay, so let's look back on our case study, and now we can map our different bounded contexts to a context map, which actually represents the relations between the different contexts. Okay, so we will focus only on shopping cart, maybe a little bit about auction. We cannot model everything here, of course. And we'll dive into the DDD building blocks. We already mentioned the bounded context and the ubiquitous language. Also worth mentioning is the value object. A value object is something that is defined by its attributes. For example, address. So what I mean, it's defined by its attributes. If we take the same street, the same house number, city, country, and everything, then we have two of those, then we still are talking about the same address, right? If two people will give me the same attributes of their address, then we can deduct that they are living in the exact same place. So this is a value object. An address is just an example, of course. An aggregate object is defined by identity. So as opposed to a value object that we gave the example of address. So of course, if I give the same street, city, country, then but with a different house number, then of course we're talking about different addresses. In an aggregate object, it defines by some kind of identity. So we can have two persons with the same name, but they're still different persons because they have different ID. But if we take the same, if we have two persons with the same ID, then we can definitely say that this is the same person. Even if the name is inaccurate, but they have the same idea, then we consider them the same person. So this is the aggregate object. Usually is defined by some kind of unique idea. Okay, an aggregate is a cluster of objects that can be treated as a unit because it aggregates many entities, many domain objects underneath. For example, if we take a customer aggregate, then it can have an address, a telephone number, all kinds of entities that aggregates under the customer entity. But when we want to know the address of the customer, we need to pull the customer, and via the customer, via that aggregate, we can find the address. Okay, not to be confused by lists or arrays or other collections. Okay, service, simple handle operations that handle several entities. We usually tend to put the operations inside the entity. So if we want to, for example, validate customer ID or phone number, then that logic can be inside the aggregate. But if we want to handle some kind of operation that handles several entities, then we will create a service that will do that for us, or it's too large to fit in a single domain object. Okay, repository is simply an abstraction of adding, retrieving, removing domain objects. I think it's quite clear. A factory is the abstraction of creating domain objects. How do we create new customer or new address? So let's get back to our case study, which is a cart auction. And we have the following, we have the following domain objects: shopping list, item, auction, consumer, actually it's a shopper. And this is the term that I used before, and address. Okay, and we are gonna implement it using actors. So just to align what is an actor, and in case that not all of us familiar with that. So we have different kinds of actors. We're not going to talk about those. We're going to talk about different kind of actors. So actors are here to help us build concurrent and scalable fault-tolerant applications. And the good thing about actor is that they encapsulates the state and nothing is shared. It's a message-driven, asynchronic, elastic. The actor system is elastic by design. We can add, reduce the number of actors the way that we need it. It's very lightweight. Actors are very, very lightweight resource. We can create them and destroy them as we need. Like I said, it's share nothing, and it's isolated process. So I think that 1 gigabyte can handle 2.5 million actors. So there is no one-to-one relations between an actor and the third. So we said that actors encapsulate the state behavior, they communicate via messages, and they're very easy to, they're very helpful to model our domain objects and the ubiquitous language. I will show you in a minute some implementation code. So actors pull the messages by order. We send an actor messages and it pulls them like a queue, FIFO, change the state, and then it can emit another message. The communication between actors are by message, okay? And this way we can model the whole, our whole domain, which is kind of the reactive systems way. The microservice can emit their events in some kind of message bus, and other services can consume it. Okay, so let's talk a little bit about event sourcing. So event sourcing, actually, okay, we defined our, we divide what we do into two actions, command and event, which command is actually something that we request to do, and it can fail or succeed. For example, I can go to the bank and request to withdraw some money, but it can fail. The bank can refuse or something can happen. As opposed to event is something that already happened. It's something that I got the money. I can see withdraw or deposit in my bank account. So if we look about the commands and the events in our systems, so we can see that the customer initialized the cart, and the event is cart initialized. He had milk and milk was added. So the events are always on a past tense. So what's good about event sourcing? First of all, we do not lose we do not lose information. So we know exactly what happened in the system by following the events. So we can persist only the events, like when we look at our bank account, we see all the withdrawals and the deposits that were made. But those are, again, only the events. Those are the facts that actually happened. Here, the same. We can only persist the events. Now, if I want to go to the final state, if something collapsed, we can just do fold left on all the events, and this will bring me to the states that I'm in. Again, if we compare it to the bank account, if I'll take all the events that happened in my bank, all the deposits and the withdrawal, all the events, I can calculate the balance. So the idea is that, like I said, we persist only the events. We put them in the event store. And one might say that if we have like a huge event store, if we take the bank account from the day I open the bank, this can take a lot of time to fold all the events to calculate the state. So we can take snapshots once in a while. And this way, if I want to calculate the state, then we can have, of course, the state in memory. But if we need to boot the application, then we can recalculate the state from the last snapshot. But if something happened to that snapshot that's not really a problem, then we go to the previous snapshot or in previous until we can calculate the whole state from the beginning. This way, we get two things. First of all, we don't lose information. We can run some analysis of all the user actions and get insights. So what I like to do is usually start with the aggregates because they're identified by idea, and we can model the application using them. I do recommend to use actors as the aggregates. They have unique idea and they hold the states and everything. For example, in our example, a shopping cart is unique. It can be the aggregate. It has its state. It has some logic, as opposed to shopping item, which is, for example, a value object. We can have the same item in our cart. It will be twice the same item. That's it. Shopping cart is unique. A customer can have several shopping carts, but each one is unique, although it will contain the same items. Might contain the same items. That's definitely, that is okay. So I just want to show you an implementation. We defined all the commands. This is the state that can be applied in our application. Those are the commands, and those are the events that are aligned with those commands. So we can see that each command can emit the corresponding event. Let's take a look in our actor. We're very close to the end, so I'll run it real fast. So first, we inherit from the persistent actor to allow us a journal and event store out of the box. So this is a trait of Akka. We have the persistent ID. This is one of the key aspects of persistent actors. And we have the receive method that can receive the commands. Okay. Once the command is received, let's focus on that. Okay. We persist the event that happened with that command. Okay. We only persist the event. So items updated, shopping cart removed. Those are the events. And we have a callback, for example, after event persisted. Of course, you can give it any name you want. By the way, the persist, again, is something that we get from the abstraction of the persistent actor. Okay, so in this example, after the event was persist, I want to add a counter to the snapshot. And this way I can take a snapshot every X events. Next, I will update the state and publish the event in case other services would like to consume it. Okay, and the receive recover will happen in case of a crash of that actor. It will reload the events and follow them to calculate the state. So we see that in case of that we read from our journal an event, what we need to do is only update the state, and this way we will calculate the final state. The other case is in case that we have a snapshot. Okay, this is how we update the state. It's very, very simple. Now, of course, the slide is shareable and you can take a look at that later. So I'll run over it very fast. Okay, so those are resources that I recommend that you can read. But of course, if you write domain-driven design, there's a lot of resources on the net. And that's it. I'm sorry.
So what is your current tech stack? Most common.
I'm a big fan of modeling using Akka actors. Monix is also very interesting library above Akka, but I think that I personally really enjoy working with Akka classic actors. I still didn't got too much having too much affections to typed actors, but it's interesting. Besides that, I am using Flink as an alternative for Spark. It's a very interesting tool that I think that it's going to be evolved and be more and more adopted in the community. So, and you know, all the rest, Redis, Cassandra, I'm also using that a lot. But as for the Scala side, yeah, Scala, Akka, did play with Monix a little bit. I forgot to mention adding matrices, like I use what the hell, but of course there are other libraries. Put a lot of matrices in your code. Matrices, when you call another function, try to time it, see how long this round trip takes to single function, complete round trip. Put counters on your actors, especially if they are created dynamically. So you know which actors are being too much created and how to scale properly. I think those matrices give you a very good inside look in your production system. So I forgot to mention that before in the recommendation, but I think it's priceless if you have good matrices, and that helps you identify bottlenecks and everything.
How you do load testing? You have something like Gatling or?
Gatling, yeah, Gatling definitely.
Yes. Yes.
So Gatling. And to be honest, for example, in one system that I'm working on, our pipeline is from the source is Kafka and the destination is Kafka. And we have like development environment, testing environment. So we just mirror the Kafka to the testing environment. And this way we can also do testing with real code, with real live code to see how the system handles that. But this is like a private case. But Gatling for load test is a very good choice.
Definitely interesting. And if you use a Kafka, are you use your own processors in Kafka? Because I look that already use input and output to Kafka.
Sorry,
but processors, Kafka processors, API. Because I see that already use input and output in Kafka, but doing something externally, yes. But I wonder why I see relative error, I see processing implemented inside Kafka.
Personally, I just use Kafka as a queue,
Aha.
as a distributed log.
Aha.
Not,
Yes. Okay.
I also would like to recommend, if we're talking about Kafka and processing and all that, the pattern of CQRS, one query read the segregation. So if we divide the code to the part that is actually writing the code, and we have like another channel of reading the code, doing that completely, it can be even different services, even different databases. Like we can write in one line, have some kind of ETL process to write a more compacted database. And if we manage to separate the reads, the writes and the reads in two different channels, we can have different scales. So for example, if I'm looking at I don't know, AliExpress or Amazon, I guess that they have much more reads than writes. How many people, vendors, they have and update the inventory and all that, as comparing to the billions of users that reading data.
Are you follow closely other languages than Scala?
Well, Rust is very interesting for me.
Rust.
I got a lot of questions about the bounded context that I mentioned in domain-driven development, and what should be included in the bounded context and what is not. So just want to clarify that bounded context is like a concept of a part of the big system, a part of the business. So bounded context, for example, if I take, like, I don't know, any kind of business, can be the accounts can be, the accountant can be in bounded context, sales can be bounded context, operations, inventory, shipping, all that are different bounded contexts. It depends on the organization and how is like the different departments in the organization. In other applications, front end can be its own bounded context. It has its own requirements, its own functionality. So definitely, and bounded context is actually can be compared to microservice. It doesn't have to be one-to-one, but it many cases, usually, even I can say that usually it is. Microservice can be considered as a bounded context, but not necessarily. Microservice can include more than one, but it usually it is. Bounded context, if we see that single operation is cross-bounded context, we want to have some kind of atomic action that includes two bounded contexts. They must be synchronic and must be completed together and all that, blah, blah, blah. It can be like a flag for us that maybe it's a single bounded context. Maybe we didn't model our application correctly. So it's like atomic action between two microservices. We should consider maybe it's the modeling that we did is incorrect. Maybe it's a single one, maybe it should be divided completely otherwise. So yes, that is definitely an issue that was worth clarifying. Okay, another question was about the persistency of events. This is actually consists with the event sourcing concept. So every action that we do, it's like starting command. We're asking something. For example, if we take our bank account, then we want to make a withdrawal or deposit. That makes some kind of change in the state. And it ends with an event. Deposit was made. It always in the past. Item was shipped. This is the event. Now we need only to persist the events. We don't need to persist the commands and not the state change. So if we look on our bank account, we can see that we have only the events there: withdraw, deposit, 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 withdraw, withdraw, deposit. And if we fold all the events, we know what is the current state. This is how, when we look at our bank account, this is how we calculate, or it actually calculates the balance. There is no record in the bank that is the actual balance. It's always the chain of events that leads to that balance. Okay, but if we want, we don't have to, each time that the application recovers or starts, we don't need to, we don't want to run all the events from, I don't know, from ancient times that can take some time. What we do is taking snapshots of the current state. So if we look at the bank accounts, then we do see like a line of balance. And then again, deposit, withdraw, and another line of balance. Those lines are actually snapshots. So when our service is recovered or going up, we don't need to read from the beginning. We can just run the events from that snapshot. And I just want to show this, this slide. So like I said, we only persist the events that happened after the command. So in the blue are the commands, the green are the events. Now in our event store, we persist only the events, and we can take snapshots once in a while. And then if something crashes and our microservice recovers, then it runs from the snapshots and fold the events afterwards. And if single snapshot is destroyed, then we can go even further and up to actually the first event.
Thank you.
Bye, guys.